Hello everyone, we are going to create the y equals cos x graph today. Y equals cosine of x graph. Okay, so y equals cosine of x. Y equals cos x. All right, so similarly to when we created y equals sine x, we took a look at the unit circle, but we only looked at the y coordinates of the unit circle. When y equals sine x, the y coordinates happen to be the exact same height as what we needed to make in on our graph for y equals sine x. For y equals cos x, that's not going to be the case because the reason that worked with y equals sine x is because the y coordinates are what represents sine x, and we used the same scale here for our y-axis as we did over here on our y equals sine x axis. So that's the reason that those heights were able to translate from the unit circle over to our graph. This time, y equals cos x, we know that the x coordinate is what represents the cosine of the angle on our unit circle. So we have to look at the x coordinates only. So I've only written in the x coordinates here on the unit circle this time around. Okay, since it's the x coordinate, it's not going to match up with the height, okay, but the length of the x coordinate will match up with the height that we need. Okay, so the length of the x coordinate from the origin will match up from the height we need on our graph. All right, so thinking about a table of values, I'll come way over here and create the table of values with my red marker. So y equals cos x. We're going to go all the way around the circle in the positive direction. So we're only going to start with 0, and then we will say pi over 6, pi over 4, pi over 3, pi over 2, and continue around the circle like that. Remember that these are the angles. Okay, so just a quick reminder about the unit circle. We always start measuring from here. Positive angles go in this direction. So this angle is pi over 6. So the cosine of that angle is root 3 over 2. So the ordered pair we're looking for is pi over 6, root 3 over 2. So root 3 over 2 goes here. All right, 0, and the y coordinate that goes with that for our function is 1, because the cosine of 0 is 1. And we will continue like that. Cosine of pi over 4 is root 2 over 2. Cosine of pi over 3 is 1/2. That's up here. Cosine of pi over 2 is 0. And you can continue around the unit circle like that. Okay, so we have 0, 1. Okay, so we start up here. Okay, so through y equals cosine x goes through the y-axis at 1. The y-intercept is 1. All right, pi over 6. Oh, I forgot to put my x-axis scale on here. I'm going to do similar to what we did before. Pi over 2. Actually, I'll go pi over 4. Yeah. Got lots of room. Pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 6 pi over 4, which is 3 pi over 2, 7 pi over 4, and 2 pi. All right. So if I look at only these exact places, pi over 4 is going to go with root 2 over 2. And let's remember that root 2 over 2 is approximately 0.7 if we just take it to 1 decimal place. So that gives us 2, 4, 6, 7. That gives us here root 2 over 2. Pi over 2 is 0. 3 pi over 4 is negative root 2 over 2. Okay, so around to that blue, that angle is 3 pi over 4. The cosine is negative root 2 over 2. Okay, so negative 0.7 around here. Pi, negative 1. 5 pi over 4, negative root 2 over 2. 3 pi over 2, 0. 7 pi over 4, root 2 over 2. And 2 pi all the way around the circle back at 1. Alright, so this looks like a nice curve like this. And this will continue, this pattern will continue forever in both directions. So you can continue your table of values, but this is what y equals cosine of x, the very first period of that, looks like. Okay, so let's talk a little bit about y equals cosine of x. How big is the amplitude? What is the maximum and minimum? What is the principal axis? And what is the period? Okay, so the amplitude, again, goes from the principal axis to the minimum, or from the principal axis to the maximum. So in this case, that is still remains 1. The maximum is 1, and the minimum is negative 1. The principal axis is still the x-axis, which the equation for the x-axis is y equals 0. And the period, how long does it take before this graph starts repeating itself? If we start here, get going here, it starts repeating itself right here, and that length is 2 pi. So the period is 2 pi. All right. Now you'll notice all of these things are exactly the same as y equals sine x, but y equals sine x looked like this. Y equals sine x looked like this. Now, where did it cross? Notice that root 2 over 2 and root 2 over 2 at pi over 4. Actually, they share an ordered pair there. Okay, and that's what y equals sine looked like. So the period is the same, the maximum is the same, the minimum is the same, the amplitude is the same, and the principal axis is the same for y equals sine x and y equals cos x. Then you will notice that y equals cos x is simply a transformation of y equals sine x if we moved that graph pi over 2 units to the left, or if we moved it all the way from here all the way over to here, so 3 pi over 2 units in the right direction. Have fun, watch the next video, we'll talk about transformational form of both.